Yes, sir. So we got to know about your experience at Texas Instruments and your view of Bangalore as a city. So moving on regarding the preparation resources for the viewers who will be watching the video. So having industry experience, how would you suggest students to study digital electronics?
Okay, yeah. So first of all, for anyone who is thinking to prepare for electronics, always start from basics. Always start from few of the basic concepts. And that I will say analog electronics as one. Start with the basics of analog electronics, basic concepts of network analysis, which covers all your RC circuits, RLC circuits, and then the basic concepts of digital electronics. Once you are done with basics of all these three subjects, then move on to the advanced topics and depending upon your interest. Like if I speak about digital, advanced topic wise, you can go for STA, static timing analysis. You can go for FIFO depth calculations. You can go for clock division circuits. Then you can go for HDL, very low voltage circuits. Then after that, you can after that you can go somewhat deeper or cover the basic concepts of the computer architecture. It basically covers the pipeline architectures, how instruction is getting executed, how your opcode is decoded, all those things. Then the memory level details like RAM, ROM, cache memory we have, all these details. So just cover all the basics and then go through these advanced topics.
Okay, sir. So regarding the basics, sir, I'm assuming you're talking about network theory, analog, digital. Digital, you told about interview questions like this. It appeared that those are typical interview questions. And before that, students
Correct.
need to cover entire digital till like end chapter, it's FSM, I guess. So that at that point, they need to cover. And can you comment on analog basics? Till what point it would be considered as basics in analog?
Okay. Yes. Okay, let me just elaborate a bit more on basics. So analog basics, what I mean by this is the basic diode workings, clipping, clamping circuits. Then you can cover BJTs, working of BJTs, common BJT topologies for amplifiers like common common emitter, common base, all these common collector, all these topologies. Then MOSFET, basic MOSFET working. You will have various different effects also in MOSFET, like channel length modulation effect. Then we have body effect. We have many other effects in MOSFETs, all those effects. Then basic topologies for MOS amplifiers. Then after this, if you want to go a little bit more ahead, you can go to differential amplifiers. Differential amplifiers, we have BJT differential amplifiers as well as MOS differential amplifiers. Then you can go to frequency compensation concepts. How the parasitics play a role, how the frequency, how the performance of the amplifiers they change as per the frequency. And then apart from that, just this one more point I would like to add is the reason of operation of either the MOSFET or the BJT. Like in for different circuits, the reason of operation for all these devices will be different. Okay,
Yes.
so what makes them go into that reason? All these things they will basically comprise all your basics. Network analysis wise, what I mean, network analysis generally forms the basic for analog also. All your KVL, KCL concepts, your RLC circuit concepts, RC circuit concepts. These all are basic your network concepts. And then digital wise basics, what I mean is all your combinational logic concepts consisting of decoders, multiplexers, demultiplexers, your normal Boolean algebra logic, number systems,
Yes.
then sequential logic, which will be all your flops, then counters, then your FSMs, Mealy-Moore machines, and then how you can design counters,
Okay, sir.
these are all basic concepts of digital.
Yes, sir. So, thanks for saying that, sir, because students are generally tending towards learning languages or not asking about projects, like what projects to make. But it's very crucial that we focus on practicing our concepts. So on that thing, how did you practice your concepts while preparing for
Yes.
placements?
Yes, so the very profound source, a very good source for practicing previous year questions, first can be the gate previous year questions. Like if you take out some 2025 year gate previous questions, you can get a good amount of questions from there for digital, for analog, for network theory also. They have good questions over there. Apart from that, there are coaching institutes which provide materials for gate preparation. So they have proper designated sets for analog, for digital, for network analysis. So you can cover questions, you can practice questions from there also. Then apart from that, during my time, there were some. third-party applications like Gate Academy and all these applications were there, which provide free quizzes. I don't know what's the structure as of now, but they have at that thing. Yes, you can put this question from there also.
Okay, so basically the chapter wise
Yeah,
questions which these coaching institutes have, they can help.
they can help, correct, because and they divide their questions also in concept wise or topic wise. So you can get a
Yes.
good amount of questions for one topic.
Okay, sir. So apart from this, did you refer any books?
Yes, and that's where I was also coming. For covering basics, what I will say is books are a good resource. I generally prefer big books from my side. For me, books basically work. I prefer books. But if you are not that much of a book person, you can go to NPTEL videos. NPTEL videos are a bit long, bit time taking, but they are a good resource. If I talk about books for covering this, Maris Meno is one book and Anand Kumar. Both of these books, they cover digital electronics concept very precisely in a very elaborative manner also. Maurice Mano you might find a bit difficult to understand at the first go, but yeah, Anand Kumar is good. For analog, I can suggest this one book, Behzad Razavi,
Yes.
Microelectronics by Razavi. It's a very famous book, and in fact, today also in industry, also people refer to that book. So you can take that book as a reference for all your basics. That's a very standard book. And yeah, network analysis, you can find many books or you can
Yes.
find many resources for it.
Yes, sir. That's
Mm.
natural, sir. Regarding reading books, people find these books texty. So, how to study a book? Like, read a chapter from starting to ending, or would you suggest reading topics directly?
Yeah. Yeah, like what I used to do, let's say I start from distal, basic distal, combinational, maybe inside I want to study Boolean algebra. So I will just open that portion from the book. I will start going through that. Whatever I found useful, whatever new concept I find, is keep on preparing notes for it. Because what losing track while reading books. So if you have notes prepared, you can easily find the reference when you're, let's say, at the next page or somewhat ahead in the book. You can easily find the reference. Yeah, okay, they are referring to this point. If you have something short noted over in your notes. So I generally prefer notes, and apart from that, in many books, when you keep on going through books, after every topic, they have some in text questions, in practice questions for that, which will basically depend upon those concepts which they have discussed previously in the book. So you can keep on going through those questions and keep on proceeding forward. So this will basically help you build your concept. And if you're not a book kind of a person, then go for videos. But I personally find video books more helpful for me.
Yes, sir. Actually, this is the situation right now that there was a gap of 2 years and senior juniors were not much connected in that. So students prefer to read books directly because they provide a sense of promise of a complete understanding, sir. And regarding that, would you also suggest solving the
Correct.
back-end questions of the chapters in the books?
Uh, I will say, okay. It's basically like the back end questions of many books. Now they are like very what should I say about them? Just something. They're not like key and they're to the point. They're very elaborative questions.
Okay.
And the questions of that way are neither asked in our college exams nor asked by any companies. What companies ask, they basically want to check a concept from you. So the questions will basically vary around one single concept. Whereas the back test questions in the books, they are more conceptual or they cover one two concepts. So
Yes.
if you have time, if you want to go, you can go with this. But after going through concepts and in-text questions, what I will suggest is go through gate previous year questions or the coaching materials questions for and those topics. They will help you.
Okay, sir. So, thanks for that, sir. So, guys, Anand Kumar and Maurice Mano are the books to go for digital, and Bezaz Rezavi is the one for analog. So, sir, apart from this, would you suggest any projects?
Yes, yes, that's what I will say. Okay, so like what industry is nowadays doing is every digital design, it starts from RTL. We have to write HDL for it. So if you have some projects based upon HDL in your resume, that will basically uh, convey them कि you are good with HDLs, you have worked with them, you understand digital. So if you are starting with any HDL for now, as a starting point, I will suggest go with Verilog, because VHDL nowadays is not used in any industry. Verilog is what every industry is using.
Yes.
Verilog. Whenever you start Verilog, you start writing small codes, like you start developing AND gates, you start developing OR gates, you start developing counters. So these are small things. By doing this, you can build your basics or build your fundamentals on the Verilog. Once you're done with this, project wise, you can start with some projects. You can design something from scratch. Few which I can suggest is, which I also did during my time, was there's something as floating point arithmetics. IEEE has two formats for storing floating point, 32-bit and 64-bit formats. So using those formats, you can try to design a complete ALU kind of thing, complete a small floating point ALU, which supports all addition, subtraction, multiplication, and all these operations. Or there are many multiplication algorithms, like for doing multiplication in hardware, there are many multiplication algorithms, like Booth is one of them. So you can try implementing that. There are many protocols available like UART, SPI. You can try implementing a simple protocol over there, which will make you also confident on your understanding of uh, Verilog or VHDL, and will convince to the interviewer also you are good at these fundamentals.
Okay, sir. So if I had to say, what are more weightage in interviews, projects or concepts?
Okay. This way I will say basically all electronics companies, they first test you on your concepts.
Okay.
They first want your concepts to be strong. Once they are done with checking of your concepts, or once they are done with their questions, then only they will come to these uh, projects, or what you have done, what experience you have. But first of all, they want you to have good, proper understanding of concepts.
Okay, sir. So, sir, if a student is in his second year, so what would you suggest to him? How would he would tread his pathway?
Okay, yeah. For him, what I will suggest is, like in most colleges, uh, you keep on getting subjects in your semesters. So keep on going through those subjects in a serious manner, in a thorough manner, get a proper. In the meanwhile, like Verilog as a subject, if I think is it varies from college to college, but very. But if it's too late in your curriculum, like in sixth semester or seventh semester, go for it early and start developing projects. But in the meantime, whatever basic concepts are coming to you, like all analog concepts, all digital concepts, whatever are coming to you, just keep on preparing for them.
Okay, sir. So yeah, so that would really help second years in the journey. And sir, regarding our current market scenario, recession has been pestering students a lot. Hiring has been meager, and companies select only one or two guys in their hiring drive. So, what would your advice be to students in this area? Because it becomes really competitive when companies are hiring less.
As of now, like many companies are, almost every company is hiring very less as of now, or even if they're hiring very selectively, hardly one two candidates. It's the bitter truth as of now. But what I will suggest everyone, ki even if you're not getting any opportunities in any big tech firm or in any big company, go for small ones. Just enter the industry. Once you enter the industry, you will start getting exposure. And
Yes.
experience, basically in industry, experience counts. Whether it's in some big tech firm or in small tech firm, experience counts. So even if you're in a small tech firm, in some startup, you start getting exposure, you start getting experience, and once the things, all these bigger firms. But yeah, start your career as soon as you can, is what I will suggest everyone.
Okay, sir. So students have to keep the long run vision with them.
Yes, correct.
Yes, sir. So, yes, sir, that was pretty much a comprehensive conversation between us. Thank you for your time with us at VLSI for all. Just one thing, what would you advise your viewers in this channel, apart from the technical stuff in general, if you want to say something?
Okay, first of all, like to all the electronic students, I will just request them. or I will just suggest them to start reading electronics. It's not that difficult as it seems. Once you start reading it, you will start developing interest in it. And second, to all those who are preparing for electronics, you will come to listen a lot from many people कि options नहीं है, companies कम हैं. Just don't listen to all those things. It's basically like if companies are less, people sitting for it are also less. So it's one to one kind of thing only. So you will get your opportunity. You will get opportunity over here. And right now, what I feel in India, electronics companies had started hiring even more. What was the scenario 10, 15 years or 5, 10 years back? It has changed. Now companies are hiring even more. So you will get your chance. So if you're preparing, keep on preparing and keep on doing good.
Yes, sir. That's one good thing you mentioned, sir. Indian semiconductor mission, it's going on in full force, and the government wants to develop electronics culture in India. So I hope that is a really good news for electronics engineers. And if everything goes fine, we'll have a good semiconductor industry developing in India. So yes, sir. So thank you for joining with us, sir, at VLSI for All. It was really nice talking to you. And I am sure that students would have got a lot of insights regarding the preparation journey and your experience at Texas. So thank you, sir. That was a really nice conversation. Looking forward to more
Yeah, thanks,
conversations.
Himanshu.
Yes.
Yeah, sure. Thanks, Himanshu. Yeah.
Okay. Okay, sir. Thank you, sir. Have a nice day.
Okay. Yeah. Okay. Bye. Thanks.